What's up, Algebros? In this video we're going to solve a polynomial inequality. Alright, so let's go ahead and dive right into it. The first thing that you want to make sure you have is 0 on one side of the inequality. I prefer to have it on the right, and if you look at the inequality here, that's exactly where it's at. So that's going to be an important element for us as we look to determine what solutions for x that we really want. So we'll get to more of that in just a few minutes. But once you have the right hand side as the number 0, what you want to do on the left hand side is factor the polynomial expression if possible. And it's definitely possible. First of all, there's a GCF of x that we can take out. So if we factor x out, what's going to be left over is x squared minus 2x minus 35 is less than 0. And the quadratic x squared minus 2x minus 35 will factor as well as quantity x plus 5 times quantity x minus 7. So this fully factored version of the polynomial function is what I would like to assign as f of x. What we're going to do next is figure out the zeros of this function. So let's imagine we're solving f of x equals 0. In other words, that would be x times x plus 5 times x minus 7 equals to 0. And we would get three answers for x. We'd get x equals 0, x equals negative 5, and x equals positive 7. What we want to do with these three zeros is plot them on the number line. We'll start with negative 5 on the left, then 0, and then 7. What's going to happen with the function is that the function's either going to be positive on these different sections that we just created, or it's going to be negative. So we know that the function is going to be 0 at these 3 points, and it's only these 3 points where the function is going to equal 0. So that means on either side of these zeros, the function's either positive or negative, and that's what we're trying to address here. We want to figure out what values of x make the function either positive or negative, and I'll show you how you can use the inequality symbol in addition to 0 to figure out whether you want the function positive or negative. The method that we'll use here is the method of test points. So basically you choose a random value on one of these 4 segments, plug it into your function, and then determine whether or not the end result is a positive or a negative number. So for instance, if we wanted to, we could select the number negative 6 since it's less than negative 5, and I'm going in order from left to right here, as you can probably tell. If x were 6 and I plugged it into the, if x were negative 6 and I plugged it into the function, using the factored form of it, we'd have negative 6 times negative 1 times negative 13. And that's a product of 3 negative numbers. And you don't really have to come up with the exact number of the product. What's really important here is whether or not the product here is positive or negative. And if you multiply 3 negatives together, the end result is a negative number. So what that means is that any x value that's less than negative 5 is going to make the function negative. And for that reason, I'm going to put a bunch of negative signs over that region of the number line. Let's pick something between negative 5 and 0, maybe negative 1. If you were to plug negative 1 into the function, your first factor would be negative 1, second factor would be 4, third factor would be negative 8, and the end result of a negative times a positive times a negative is a positive. So what this means is that any value of x between negative 5 and 0 is going to make the function positive. And you continue doing this process until you've checked all of the different sections of the number line. So for example, if I picked 1, since that's between 0 and 7, I would have 1 times 6 times negative 6, and the end result of all that stuff there would be a negative number. And if we were to maybe plug in 8 into the function, we'd have 8 times 13 times positive 1, and the end result of all that is a positive number. So you can tell that or you can obviously see that there's a pattern that goes from negative to positive, negative to positive. I just want to forewarn you that that's not always the case. There are situations where the pattern sort of breaks up. We could go from a negative to a negative, or a positive to a positive. So it's always just best to try each and every interval, regardless of whether or not you see a pattern. So just to be on the safe side, always check the sections that are created by plotting the zeros on the number line. So check them all. Alright, so which values of x do we want? Do we want the values of x that make the function positive, or those that make it negative? If you go back up to the original inequality, where we have 0 on the right hand side, or if you look at either of these inequalities with 0 on the right hand side, paired together with the inequality symbol, the original problem is saying it wants this polynomial to be less than 0. And of course, that's obviously what our factored form version of the inequality says as well. But regardless, if we want something to be less than 0, and thinking in terms of numbers, we want the numbers to be negative. And we know which values of x make the function negative. It would be those going from negative infinity to negative 5, and those between 0 and 7. So at long last, we'll go ahead and write out our solution interval notation, parentheses negative infinity, comma negative 5. And I'm not going to include the negative 5 since there is no bar underneath the inequality symbol. I'm going to union this with parentheses 0 and 7. And similar reasoning for why there's a parenthesis around 0 and 7. Okay. So you would type it in just like that, parentheses negative infinity, comma negative 5, union, parentheses 0, comma 7 parentheses. And there we have it. That's how we solve this polynomial inequality. As always, if you have any questions, let me know. Otherwise, thanks again for watching.